have my medical director on the line in the middle of the night from Bangalore in India. So thank you very much. My name is Mohan, and as I was introduced, I am one of the co-founders and co-inventors of the tumor-specific electroporation being innovated by Scandinavian ChemoTech, a company based in Sweden and has been around since 2015. And end of 2016, we made our IPO on NASDAQ in Stockholm. And we have today operations in India and in United States, Middle East, and Sweden. We made, as an inventor, what we would call a 180-degree in our philosophy of treating cancer. Many other therapies like surgical procedures, radiation, and ablative technologies focusing on removing or killing cancer cells as quickly as possible. We at ChemoTech, and when we developed the tumor-specific electroporation, our philosophy is why create damage and collateral damage or disturbing the human body's own system? What happens if you can find a balanced treatment that works with the body instead? Our therapy is built on an electrical field that stimulates the cells in cancer tumors to become more vulnerable to low dose of chemotherapy and to change their character to be more warmer or hot tumors, meaning that they would be more efficient for immunotherapy and immune responses. By working with electricity, the magic of electricity is that it behaves differently in different bodies, different tumors, and different locations. And that is the key when it comes to not creating damage. So instead of the older technologies of electroporation that's been static and focusing on damaging and kill this cancer cell as quickly as possible, ChemoTech, we found out that if we can balance the electrical field, every time it's being used to different locations and different tumors, we create a better treatment option where we spare healthy tissue and we create a more longer treatment effect and creating apoptosis instead of necrosis. We have today 3 operations. We have one which is focused on superficial tumors, being launched more in the emerging markets. And the same kind of product we have launched here in North America and Europe for taking care of our pets, cats, dogs, and even horses that suffers from cancer. The third one is what I would say one of the most interesting part of our operation today, and that is to treat deep-seated, very complex tumors. And for that market we're focusing on Europe and North America. So why are we here? We're looking to find a way to do this therapy more minimal invasive by a laparoscopic partner or robotic surgical partner. Obviously, we're also here to find some fundings and financial partners to help us to fund our new operations within pancreatic cancer and other deep-seated tumors to a total amount of $6 million split up in 3 tranches within the next 3 years. So by that, I hope that the technique is going to work. So I would like to introduce Dr. Suhail, our medical director, to share some of the latest knowledge and findings we have done in the pancreatic field and immunological field. So Dr. Suhail, now it's your first slide.
Thank you, Mohan, and good afternoon, everybody. This is Dr. Suhail Mufti from Bangalore, India. I'm an oncopathologist by training, and I'm trained into translational medicine from the University of Edinburgh and have been into cancer research for the last 2 decades with major assignments on oncology projects from Sanofi and Novartis. I manage the medical affairs of Scandinavian ChemoTech for the operations and research of tumor-specific electroporation. Next slide number 9, Mohan.
You can.
Thank you. So, as Mohan mentioned, tumor-specific electroporation not only does electrochemotherapy on superficial and deep tumors, but it is also an immune therapy. It does immunomodulation on the tumor microenvironment with the release of neoantigens, tumor-specific neoantigens, and sensitizes the lymphatic system, sensitizes the T lymphatic system with the recruitment of CD8 positive T cells by the sensitization of the dendritic cells, which go to the lymph nodes, and CD8 positive cytotoxic T cells are recruited, converting a cold tumor into a hot tumor. It's important to mention here that it does it much better and in a much safer way compared to radiotherapy, and never information regarding the effect of radiation on the lymphatic system warrants that a safe and effective neoantigen sensitization of the lymphatic system is important. And even the lymph nodes, as has been recently published by the University of California on the March 17th, that lymph nodes have to be patent and lymph nodes have to be competent to do the immunological sensitization of the microenvironment. Next slide, Mohan.
Yeah. Done.
It's important for pancreatic cancer treatment, which is a major medical need in oncology at the moment. Local regional control or local control of the tumor in advanced and unresectable pancreatic cancer is still a need, and it is important because we know with data that almost 1/3 of the patients still have mortality because of the local effects of the tumor. Local regional recurrence is responsible for patient mortality in the presence of even limited distant metastases. And it has been seen that 3-year death rate from local regional recurrence alone is 23 to 28%, regardless of chemotherapy. So local treatments are important along with the combinations which may be required for metastatic cases. So that is why tumor-specific electroporation does safe electroporation, does safe electrochemotherapy, along with creates immunological cell death apart from apoptosis of the tumor cells. Next slide, Mohan.
Yeah. And we have 1 minute, so we have to roll up a little bit quicker.
We have done recently 2 cases of pancreatic cancer at Ulysses Hospital, Ukraine. And these are the pictures from those cases. And you can see on the top right that this is what we are doing with open surgery, providing electroporation. On the left, you can see there are MRI images, how the tumor was unresectable. And on the right side, you see the histology images, the right extreme one of the tumor before treatment and the left one after treatment. And you can see the effect of the lytic effect of the therapy on the tumor.
Okay.
Next slide,
yep.
Mohan. These are the immunohistochemistry slides, and you can see the recruitment of CD8 positive T cells and CD45 positive T cells. So these images, these immunohistochemistry images, show that tumor-specific electroporation converts cold to hot tumors and creates an opportunity for immunological cell death and for combinations with immunotherapy.
Okay.
Next slide, Mohan.
All right. So that was just to give you a little idea of how the therapy worked here in Ukraine with the open surgery. So now just if we can just end Dr. Suhail with the phases in our clinical projects as we a little bit over time.
This is the team at Ulysses Hospital, Ukraine, and I would like to highlight that we are working at combination therapies of tumor-specific electroporation with anti-PD-1 and PD-L1 inhibitors, and TSE also has a radiosensitizing effect so that we can decrease the radiation dose for various tumors. It's potentially a potential better immune modulation compared to radiotherapy with no adverse effect on dendritic cells and T cells. Next slide,
Yeah,
Mohan.
it's next.
This is the complete project on tumor-specific electroporation for pancreatic cancer. We are working in Ukraine with Ulysses Hospital. We are taking the trial to Africa, to Rwanda, and the entire of East Africa, including Kenya. And we are moving to US and to Europe, and we're also taking the pancreatic cancer study to India. As Mohan mentioned, our major endeavor today is to take TSE through the minimally invasive route, through the robotic or the laparoscopic routes for multiple applications in pancreatic cancer.
Thank you so much, Dr. Sohail. And with that, I would like just to summarize, because I know I'm a little bit over time here. The product is CE marked in Europe. We are not yet started the FDA process here. Something our strategy, we build our strategy to do that with a partner here in the United States. So that is what our aims are for this year. And together with building a network of investigators from Europe down to Africa, as we see here, Scandinavia, and here in United States. So with that, I would like to thank the audience for listening.